Hey guys, we'll be continuing with our example on the topic of velocity time graph. Let's see, we have another example here. We'll just see how to solve these examples, and I hope by this time you will have a firm grip on this topic because this is very important. Kinematics is very important for physics. So I hope you have had a pretty good time with the kinematics lectures because we have had a very detailed talk on that. So let's just do this example here. Jeremy has recently taken up snowboarding as a hobby. He's practicing making smooth turns while traveling with slope inclines. The velocity time graph below depicts his motion traveling up an embankment and part way down. So he's moving up an embankment and then way down. Use the graph to answer the following questions. So this is the graph, and as you can see, again, first of all, make yourself understand that this is a velocity time graph. So if you need to, then do it 100 times, but be sure that you remember throughout the question that this is a velocity time graph. So determine Jeremy's acceleration at 8 seconds. The first question here. Let's see. Let me just change the color here. We haven't used, I think we haven't used this brown in a while. So we just take brown. So determine Jeremy's acceleration at 8 seconds. At this point, his acceleration at this point. So first of all, you should know that the slope of a velocity time graph gives us acceleration. So the slope gives us acceleration. Now you should know that the slope of this line should be calculated to find out the acceleration. I mean this entire line, and the slope of this entire line at any point would be the same since it's sloping the same way throughout. It's a linear, it's linear and it's a straight line. The slope is the same throughout a straight line. So we can just take any point on this line and find out the gradient, and that would give me his acceleration at 8 seconds. It would be the same at 8 seconds, it would be the same at 4 seconds, sorry, not 4, but 4.5 seconds here. It would be the same here, the acceleration would be the same here since it's a straight line. So the acceleration is not changing, the gradient is not changing, and so the acceleration is not changing. So let's see, let's just find the gradient of this line. Just take 2 points here. Let me take this one starting point because I can figure out this is 4, this is 5 here, and this is 12. So the first point here is 5 and 12. You can take any points and you will have the same gradient. Which take this one, this is 13, 14, 14 and minus 6. 14 and minus 6. Let me just find the gradient of this line. The gradient would be minus 6 minus 12, y2 minus y1 divided by x2 minus x1. 14 minus 5. This would be minus 18, minus 6 minus 12. 14 minus 5 would be 9. So this would give me, if you use your calculator, this would give me a gradient of minus 2. Now the gradient of the velocity time graph gives me the acceleration. So since the gradient is minus 2, this means the acceleration is minus 2 meters per second square. Ask yourself, what does this minus tell me in the acceleration? This tells me that the speed or the velocity is decreasing. This is, he is slowing down. You can see he was at a velocity of 12 meters per second till 5 seconds, and then he started to slow down, and he slowed down and kept slowing down till this point where his velocity was 0. He stopped for a while here, for like just a second or two. He just stopped here, and then his velocity started getting negative. So what does a negative velocity tell you? A negative velocity tells you that he's moving with this much magnitude, but in the opposite direction. He has turned around. He was moving like this first, then he slowed down for first 5 seconds, then he slowed down and came to a halt. This was his deceleration of 2 meters per second square, or acceleration of minus 2 meters per second square. You can say anything. And then at this point, this was this point. This was 11 seconds. At 11 seconds, he stopped. And then he returned towards his original position. And that is why the velocity is negative. So first, try to make out what the graph's telling, and then start attempting the question. Okay, let me just erase this. So the acceleration was minus 2 meters per second square at 8 seconds. Let's see. I can't see here. Determine the distance Jeremy traveled from 0 to 5 seconds. Now, second question asked us, determine the distance traveled from 0 to 5 seconds. So, this is 5 seconds. Distance, again, remind yourself, distance is given by the area under VT graph, or a velocity time graph. So you simply have to find the area of velocity time graph till 5 seconds, since you want the distance till 5 seconds. So the area that you need to find out, this is the area that you need to find out. So you can see that this is, let me just change the color. I just get bored with colors if I keep using them for a long time. So you can see that this is a rectangle. So area of a rectangle is given by length times width. So take any one of the heights, or this one as the length and the other one as the width. Let me take this one as the length and this one as the width. So the length is 5, and the width, or the height, width is let's not call it height, let's just call it width. The width is 12 meters, 10, 11, 12. This is 5 times 12. This is 60. Just use your calculators here, and this is 60. So since the area is 60, the distance moved in the 5 second, or the displacement, would be 60 meters. Always remember the units here. So this is the second part, and it was easy. At what time did Jeremy begin to travel back down the embankment? So when did he return? We know that when he would have to return, when he would have to turn around, there would be just a little instant when his velocity would be 0. He might just come here, stop for a while, and then turn around. Or even if he turns around like this, there would be this little instant when his velocity would be 0. Because the graph has to switch from a velocity time graph. The graph has to switch from the positive side to the negative side. So it would have to come down like this. And there will be some point where it will touch the x-axis, or the 0 mark. So that would be the point where it's returning or turning around and moving in the other direction. Because a negative velocity, always remember, a negative velocity tells us that person has returned, he is moving in the other direction. If the positive velocity is moving in this direction, a negative velocity tells you that he is moving in this direction. So in this case, we will see when the line is crossing from the positive to the negative, the positive part to the negative part, and in between there has to be a 0 mark when it will touch the x-axis. That will be the exact moment when he will turn around and start his return journey. So we can see that graph crosses the x-axis at this point. After this, he turns around and goes in the other direction. So when did Jeremy begin to travel back down? This is 9, 10, and 11 seconds. This would be 60 meters, and this is acceleration at 8 seconds is minus 2 meters per second square. So guys, we are done with another example. If you have any confusions, just comment and I would reply to them. And that would be it for the speed time graphs and distance time graph, and we'll be moving on to the next chapter. If you have any confusions, kindly revise some of the videos that I've posted earlier, and if you have any problems, just let me know. Thanks for watching, guys.